Alright, so today's video is going to be on law of signs again, but I'm going to talk strictly about word problems in this video. Um, Today you'll see just basic word problems. Sometimes the picture will already be drawn for you, but I think the key thing when it comes to solving these types of word problems is you really want to be able to get a good picture. So I'm going to go over two things real quick. So angle of elevation. So remember, angle of elevation has to come from a horizontal line. So somewhere in the problem you've got to figure out where it would make sense logically that there would be a horizontal line, and then it rotates and looks up either direction, and this would be our angle of elevation right there. Then there's also angle of depression. Okay, and so angle of depression has a horizontal line as well, but then you're looking down from a spot, so now it's looking down, and from that horizontal you're looking down, so theta would go that way. And so those are going to be two, but then sometimes you just have a picture that you just have to make sense of and kind of just think about what would be the most logical way to draw the picture. However, once you get the picture, which is the key thing, once you can take the word problem and make a picture, we should be able to get a triangle, right? And that triangle should be able to be solved by using the law of signs. So if you can't get a picture that's a triangle, or your picture's not turning into a triangle, we probably should go back and read the problem, because when you use the law of signs, you have to have a triangle and you have to know three pieces of information. You have to know the angles, two angles in the side, or angle, side angle, or you have to know two sides, two sides and an angle, right? And so those are kind of your three scenarios where you would be able to use law of signs. If one of those three scenarios doesn't pop up in your picture, then we probably haven't drawn a good picture. Alright, so let's get started. So I've got one here. It says fire towers A and B are located 10 miles apart. They use the direction of the other tower as 0 degrees. Rangers at fire tower A spots fire at 42 degrees, and rangers at fire tower B spot the same fire at 64 degrees. How far from tower A is the fire to the nearest tenth of a mile? So let's just try to take this, let's take this in stride, right? So we've got fire towers A and B, and they're located 10 miles apart. So I'm just going to go and I'm going to take a point here and a point here, and I'm going to say I've got them A and B, and they're located 10 miles apart. Hopefully that makes sense. Alright, so then it says they use the direction of the other tower as 0 degrees. So essentially based off the way you've learned how to graph angles, right? If I'm looking at this guy, I'm calling it 0 degrees. So then as it rotates up, use a different color, then as it rotates up, it says tower A spots it at 42 degrees. So 42 degrees, probably something like that. And I'm just going to draw a line for as far as I can. And so dudes in fire tower A, they spot that fire at 42 degree angle, but 0 is that guy over here. Same thing then, if I'm looking from B, it says they use the other tower at 0 degrees, so kind of weird, but apparently that's 0 degrees. And then it says spot the same fire at 64 degrees. I'm just going to draw that. I'm going to say that this guy is 64 degrees. And so hopefully that makes sense, kind of how they're looking at it. So where they intersect is going to be what? This is going to be where things are on fire. Fire. So things are on fire there. Somebody's got to get there, take care of it, put it out. So we are trying to now figure out how far from tower A is the fire to the nearest tenth of a mile. So I'm going to call that X. Whoops. Alright, so that's going to be our X. So we're going to define our variable. We've got a picture, then we're going to say let X be the distance, right, from tower A to the fire. Okay, and now we're going to start solving it, right? Set up an equation to solve. Let's take a look at our picture. Right now it's just a triangle. We could probably find this missing angle since we have angle, side angle given to us. We could probably find this missing angle so that I have a complete proportion. So 42 plus 64 is 106, and 180 minus 106, what's that, 74 degrees? So that would be 74 degrees. Now that I have that, I can set up my law of sines. So sine of 74 degrees over 10 equals sine of 64 over x. And now that we've got that, we can solve for x. We're going to cross multiply, divide. X is going to equal, right, 10 sine of 64 over the sine of 74. Make sure your calculator is in degrees, and you should be able to get x. And the x is going to be approximately 9.4 miles. Okay, round to the nearest tenth, so 9.4 miles. And so if you're going off of our 6 steps that kind of help us make a word problem make sense, here's number 1, right? There's our picture. Number 2, okay, there's our definition of a variable. Number 3, there's our equation that we're going to use to solve. 4, here's our work. 5, here's our answer. And then we can say the fire, it's number 6. The fire is 9.4 miles away from Tower A. Cool. And there we have it. So once again, key things: get a picture drawn and make sure that picture is a triangle. And if you can do that, then you should be able to use law of sines. Alright, so let's bring angle of elevation into the problem. I forgot to ask a question in this problem, so you see my handwriting there. Noob move by me. But anyway, it says the path of a satellite, right, orbiting the Earth causes it to pass directly over 2 tracking stations, A and B, which are 53 kilometers apart. When the satellite is on one side of the 2 stations, the angles of elevation at A and B are measured to be 88 degrees and 84.6 degrees respectively. How far is the satellite from station A? Okay, so first you got to focus in on this respectively part. Respectively means kind of in the same order. So they first said angles of elevation at A and then B, and so that means this is for A and this is for B, right, respectively. So let's get a picture drawn. So we've got the satellite orbiting the Earth. All right, I'm actually going to draw the stations first. Here's A and here's B. And I'm going to ask you a question. Hopefully you can answer it. If you're not sure what the answer is, hit pause and think about it. All right, this is 53 kilometers apart. Okay, it says the satellite is on one side of the 2 stations. So the question I have for you, based off the angles of elevation that they've given you with the satellite, let's say this is the satellite. Oh wow, what a terrible satellite. I don't even know what satellites look like, okay? But like, say that's your satellite. Boom, boom. Does that even fly? But anyway, right, say that's satellite. Would it be on the left side of your picture, or would the satellite over here be on the right side of the picture based off the information that they've given you? Okay, if you want to hit pause right now, I'm about to spoil the answers. If you want to hit pause, all right, and think about it, but should it be on the left side or the right side if the angle of elevation for A is 88 degrees and the angle of elevation for B is 84 degrees? All right, spoiler alert, here you go. So spoiler alert is this: it should be on the left side based off the way I drew it. And the reason being is because, think about it, if you were at station A, if the angle of elevation is 88, yes, let's think about that. Here's your horizontal that angle of elevation has to come from. If your angle of elevation is looking up, right, looking up at the satellite, it would have to be closer because it's going to have to look up higher, so it's 88 degrees. And I probably didn't draw this very good to scale, so disregard, but once again, this would be the angle of elevation for B, and it wouldn't have to look up as far because it's further away 84.6 degrees. Okay, and that's all you actually really have in this picture. The last thing we should do is define the variable. And so how far is the satellite from station A? I guess we're looking for this guy. We'll call it x. So let x be the distance. Of the satellite from station A. Okay? So you might have to actually work with it. This is the key thing of getting a really good picture, is now you need to fill in some information that you have. So we could probably find this guy. How would we find that? Probably subtract from 180. So I think that seems like 92 degrees. Seems like a good thing. So that would be 92. And then that would allow us to find this angle over here. So I would add 92 degrees plus 84.6 degrees. Feel free to hit pause if you want to try to solve the rest on your own. And I'll run through it. But you should get 3.4 degrees. And now you have enough information to find x. So our equation is going to be x over sine of 84.6 equals 53 over sine of 3.4. I'm going to multiply by the sine of 84.6 on both sides. X is going to equal 53 times sine of 84.6 divided by the sine of 3.4 degrees. And as long as I'm in degrees in my calculator, it should be good. And after you plug it all in, you should get that x equals 889.7 kilometers. So the satellite, we're going to finish our problem, make sense of our answer. The satellite is 889.7 kilometers away from station A. Alright, cool. I got one more for you. Angle of depression. And so hopefully these are making sense so far, but we'll do one more. I've got a pilot. He's flying over a straight highway between two mileposts, A and B. She determines the angles of depression to two mileposts, A and B, which are 5.5 miles apart, to be 28 degrees and 45 degrees respectively. Find the distance of the plane to point A. So let's make sure that we see this a little bit clearer. This is probably a little bit more like the fire, if you will, because notice it says that the airplane is between the mileposts A and B. So let's get the milepost drawn. So I'm going to say this is milepost A, and we'll go with milepost B over here, and that's 5.5 miles apart. But then it says the airplane, right? This is my beautiful airplane. Thank you for loving it. Look at this guy. He's killing it. So there's my airplane. Oh, let me get a little tail. There it is. Alright, so that's my airplane. Alright. Now, the airplane's flying straight. And if it's not flying straight, then we're in trouble. But let's assume that the airplane is flying straight and parallel with the ground, the highway, right? So here's our airplane. It then, angle of depression, right? Angle of depression looking down, right? So, and then it says 28 and 45 degrees respectively. 28 being for A, correct? And B for 45. So as this person looks down, the pilot, right? They look down and their angle of depression here would be 45. Okay. Then as they look backwards, apparently, they're gifted in the ability to see behind them as they fly an airplane. I don't know. I don't fly airplanes, so feel free to let me know how that works. But anyway, they're able to then measure how far away milepost A is, and they said that that angle of depression is 28 degrees. All right, and that's all you know. So my guess is we should probably be able to find stuff, because we're supposed to be able to find the distance to point A. So I'm going to call this x. All right, so let x be the distance to point A. Cool. There it is. X is the distance to point A. Now, couple things. If you're on your geometry game, I'm just going to point this out. Straight highway. Straight path of the airplane, aka parallel lines, cut by a transversal, right? So that means I know this angle. That angle is 28 degrees because alternate interior angles are congruent. Same could be said over here. I know this guy. This guy's 45 degrees because once again, cut by a transversal. Alternate interior angles are congruent. And then that leaves me my last angle, which you probably could have found also. And that is going to be after I add 28 plus 45, right? 28 plus 45 is how much? That's like 73. And so 107 degrees. Hopefully that's good. Okay. And so then you can now set up a problem to solve for x. So x over sine of 45 equals 5.5 over the sine of 107. So I'm going to multiply by sine of 45 on both sides. X is going to equal 5.5 times sine of 45 over the sine of 107. And x is going to be approximately, and if you plugged in your calculator correctly, approximately 4.07 miles. So we can say the plane is 4.07 miles away from point A. Alright, so the key to word problems is the picture. The picture is critical. So if you can get a good picture drawn, you should be able to see a triangle that you could then use the law of sines with in order to find your variable. Okay, make sure you use those 6 steps. They're really helpful, and have a great day. Alright, see ya.